it says that there are a limited number of possible rational solutions of your polynomial. That's p of x equals 0. That's the polynomial. To find all of the possibilities, we are going to take a factor of the constant term. That's the one that has no variable with it, usually listed last if it's in standard form. And then we're going to put it over or divide it by the factors of the leading coefficient. That's the one with the highest degree, which if written in standard form is usually first. And again, these are all just possible solutions. It doesn't mean that they are solutions. And it says that these roots can be both positive or negative. Everybody ready? I got to sneeze, sorry. All right, let's take a look at that first one. My polynomial is 2x to the third plus 2x minus 9 equals 0. And what we're doing is we're not finding the solutions. We're listing all of the possible rational solutions. We could still have irrational solutions, which we will get to later down the road. So if I'm going to start with my constant term, what's my constant term in this polynomial, the one with no variable? Is 9, right? We don't think about the signs. We just think about the number, 9. And we want to list all of its factors. What are all of the factors of 9? 1, 3, and 9, right? Because 3 times 3, same number. Do you agree with that? Okay. And then we're going to look at the coefficient of our leading term. That's the one with the highest degree. What's the leading coefficient? 2. And we're going to list the factors of that number. What are they? 1 and 2. Okay, this is not hard at all. You just have to kind of pay attention to what I'm doing real quick. And after you see it a couple of times, you'll be like, oh, that's really easy. And it takes a couple of seconds on each question. So what we do is I'm going to start with the first factor of my constant term. And I'm going to divide it by the first factor of my leading coefficient. Okay, and I always put a plus or minus in front of it because they can be both positive and negative. So we're going to go plus or minus. What is 1 divided by 1? 1. Okay, so that's going to be one possible set of rational solutions, positive and negative 1. Is everybody ready? Okay. Then we're going to do the same thing with this one that is a factor of 9. Let me change the colors. Okay, so the same thing here, but we have to divide it by the other factor of my leading coefficient. What's the other factor? 2. So we're going to go plus or minus 1 divided by 2. We just leave it as a fraction, and that's 1/2. A little bit of sense, sort of, kind of. Now, I've taken the 1 for the 9, and I've divided it by both of the factors of my leading coefficient. I divided it by 1, and I divided it by 2. So then I'm going to repeat the process, this time with the 3. Okay, I'm going to go 3 divided by 1. What's 3 divided by 1? 3. Okay, so I put plus or minus in front of it. And then I do the same thing with the 3 and the 2. So it's going to be plus or minus 3 divided by 2 is not an even number, right? So we just leave it as a fraction. Reduce if possible. Can 3 over 2 reduce? No. Okay, so I used the 1 with both the 1 and the 2 for the first term. I used the 3 with the 1 and the 2 for the first term. Now I'm going to do the same thing with the 9. So I'm going to take 9. Whoops, I didn't mean to do that. I'm going to take 9, and I'm going to divide it by 1. We're going to put plus or minus in front of it. 9 divided by 1 is 9. And then we're going to do exactly the same thing with the 9 and the 2. Does 2 go into 9 evenly? No, so we leave it as a fraction. Can that reduce? No. Do I have any other factors of that constant term left? No. Do I have any other factors of the leading term that I haven't used? There's your answer. That's your list of possible rational solutions. Plus or minus 1, plus or minus 1/2, plus or minus 3, plus or minus 3/2, plus or minus 9, plus or minus 9/2. If you get the same thing twice, so meaning if I ended up with a 2, a plus or minus 2, and then later on down the road I had something that reduce like 4 divided by 2, you don't have to repeat the same answer twice. You only need to list it once. Everybody kind of okay? Yeah. Nope. Just as long as you have them, all that matters. Is everybody okay with that? Okay. So we're going to do the same thing. That's just the directions. It's going to tell you to use the rational zero theorem, the rational root theorem, called several different things, but it's just listing all of the possible rational solutions. We're not actually solving. We are just listing all of the possible solutions. I'll do number 2 again with you to just kind of get you used to what we're doing. Then I'll let you try 3. Okay. List all of the factors of your constant term. That's the term with no variable. List all of your factors with your leading coefficient. That's the coefficient of the highest degree. And then we're going to start. What are my factors of 6?
1, 2, 3, 4.
There we go. Okay. 1 times 6, and then 2 times 3. Those are my factors. And what are the factors of 3? 1 and 3. Are we ready? Okay. Starting with the first one, constant over leading. So it's going to be plus or minus 1 divided by 1, which is just 1. Do you think that's always going to be a possible set? Yeah, positive and negative 1 are always going to be, no matter what your terms are, will always be a set of possible solutions. Then we're going to do the same thing with the 1 again, but this time we're going to go 1 divided by 3, which would just be plus or minus 1/3. Is everybody okay with that? If it helps you, you might want to, once you use the one of the factors of your constant term, if you've used it every time, you might want to maybe cross it out so you know you're done with that one and you can move on to the next one, if that helps you. Then we're going to do the same thing, with a 2. So it is going to be plus or minus 2 divided by 1, which is just 2, right? And then we're going to do the same thing with a 2, but this time to the 3, plus or minus 2 divided by 3, which does not divide evenly. So I'm just going to leave it as plus or minus 2/3. And have I used that 2 with both of the other factors? So I'm done with it. I'm going to cross it out so I don't have to look at it anymore. All right, then we're going to do the same thing with a 3. We're going to go plus or minus 3 divided by 1, which is just 3 divided by 1? 3, okay. And then we're going to do plus or minus 3 divided by 3. What does 3 divided by 3 reduce to be? 1. And we already have 1, so we don't have to list it again. Okay, you don't need to do 3 divided by 3. 3 divided by 3 reduces to be 1, which is already on our list. So that means I don't have to list it again, and I'm done with that 3. And then I do the same thing. Let me erase all my highlighting. With the 6. So we're going to take plus or minus 6 divided by 1, which is just plus or minus 6. And then if I do plus or minus 6 divided by 3, what does that give me? 2. Do I already have 2? So I don't need to list that again, which means I'm now done with that 6. And this is the list of possible rational solutions. Order doesn't matter. As long as you have them all listed, it is fine. Okay? The order in which I listed them doesn't matter. It's just as long as you have them all there. Now, sometimes your list is really short and sometimes your list is really long. It just depends on how many factors each of your numbers have. So I would like for you to try number 3. This one might be a little bit longer of a list because 18 has more factors, and so does 6. However, they might reduce to be something you already have listed, so it might not be that long. So if you will just take a couple of minutes and try number 3. factors of 18? 1, 2, 3, 6, 9, 18. 2, 3, 6. Ready? Okay. Plus or minus 1. Plus or minus 1/2. Plus or minus 1/3. Plus or minus 1/6. That's what I get from using 1 with each one of those. Is everybody good with that? Okay. Then we're going to do the same thing with our 2. So it's going to be plus or minus 2/1. 2/2 reduces to be what? 1, which I already have. Then 2/3 does not reduce. What about 2/6? What does that reduce to be? 1/3, and I already have 1/3 as well, right? So I don't have to list that one again. All right, so I'm done with the 1, I'm done with the 2. Now we're going to do the 3. Plus or minus 3/1, which is 3. Plus or minus 3/2, which I do not have, and that does not reduce. 3/3 reduces to be 1, which I already have. And 3/6 reduces to be 1/2, which I also already have. So I'm done with the 3 now. Now I can do the 6. I'm going to come down below here, plus or minus 6/1. What does 6/2 reduce to be? 3, which I already have. What about 6/3 reduces to be 2, which I have, and 6/6 reduces to be 1, which I also already have. Okay, so I'm done with the 6 now. Everybody getting the idea of how this is working? Okay, let's start with the 9. Plus or minus 9/1. Plus or minus 9/2 does not reduce, and I do not already have that. What about 9/3? What does that reduce to be? 3, which I have. What about 9/6? That reduces to be 3/2, which I also already have. So that one's done as well. And now we can go to our 18. Plus or minus 18/1 is just 18. 18/2 is 9, which I have. 18/3 is 6, which I have. And 18/6 is 3, which I already have. So that one was a little bit longer of a list, right? But still not hard, I don't think. Not really. Is everybody okay understanding? All right, last one. Try that. What are the factors of my constant term? Just 1, right? And then 8 would be 1, 2, 4, and 8. Okay, remember, constant over leading, plus or minus 1 divided by 1 is just 1. And then I'm going to go plus or minus 1 divided by 2 is 1/2. Plus or minus 1 divided by 4 is 1/4. And then plus or minus 1 divided by 8 is 1/8. And because I don't have any other factors of my constant term, that is my complete list of possible rational solutions. Everybody kind of okay with that?